Hello, everyone. Welcome to the second webinar organized as part of the project From Raw Collection to Digital Collection, co-funded by the European Union. The aim of the project is to enrich the common European data space for cultural heritage using advanced 3D and XR technologies. So before we get started, I'd like to go over a few housekeeping items to ensure everything runs smoothly. So please make sure your microphones are muted during the presentation to avoid any background noise. If you have any questions, feel free to ask them in the chat and we'll address them either during the presentation or at the end, depending on the timing. For any technical issues, please reach out via the chat and we'll do our best to assist you. So thank you all for being here. And let's start. So today we will present a step-by-step overview of the 3D digitization process for cultural heritage items, from choosing an object and preparing it for scanning to recording and capturing details, data processing, and data presentation. So let's start by taking a closer look at the importance of 3D digitization and the far-reaching benefits it brings. So one of the most significant benefits of 3D digitization is its ability to preserve cultural artifacts in a digital format. Cultural objects and sites, whether they are ancient sculptures, manuscripts, or architectural ruins, can be fragile and subject to decay, or even at risk of being lost entirely due to environmental or human factors. Digitizing them helps safeguard these treasures for future generations. So, for instance, the Altamira cave in Spain, which is famous for its prehistoric paintings, was digitally scanned to create a replica. And this replica, which is based on 3D scanning technology, allows people to experience the cave and its artwork without damaging the original site. Another great benefit is improving the accessibility. So with 3D models, we're able to share and provide access to these artifacts in ways that were previously unimaginable. Digital replicas can be made available to researchers, educators, and the public, even when the physical object is located in a remote or restricted place. This could mean objects in a far-off museum, archaeological sites in dangerous or difficult-to-reach locations, or even items found underwater. So, for example, the wreck of the Titanic was scanned and turned into a detailed 3D model, since the site is extremely difficult to reach. This digital model allows researchers and enthusiasts to study and analyze the Titanic's structure, leading to new discoveries. Moreover, these models allow people with visual impairments to explore cultural heritage through tactile experiences. 3D printing, for instance, can enable people to touch and feel replicas of objects that they otherwise wouldn't be able to experience. From a research and educational standpoint, 3D digitization is revolutionary. Scholars can study artifacts without needing to physically handle them. This reduces the risks of damage and, depending on the quality of the scan, can offer deeper insights into their original form, structure, and context. Researchers can manipulate the models, zoom in on details, and conduct virtual analyses that would be impossible with traditional methods. 3D digitization also plays a crucial role in reconstructing damaged or incomplete artifacts. This technology helps archaeologists and conservators visualize and understand what the original item might have looked like before it was broken or decayed. In some cases, it may even be possible to virtually restore artifacts by creating 3D models of missing parts. That said, it's important to note that 3D digitization doesn't replace physical preservation or protection. Rather, it serves as a powerful tool to enhance our understanding and safeguarding efforts. The digitization process doesn't prevent physical damage, but it can provide a backup in case of loss and help us to learn and share knowledge in new ways. So, what are some key factors to consider when selecting what objects to digitize? Selecting an object for 3D digitization requires careful consideration of both the practical and strategic factors, such as the purpose, condition of the object, reusability, value, access needs, and the audience for the digitized model. By evaluating these aspects, you can make informed decisions on which cultural heritage objects to digitize and ensure that the process serves its intended purpose effectively. It's essential to balance the benefits of digitization with the preservation needs of the object. So, what can be digitized? Different types of objects can benefit from digitization in unique ways, and each type of object presents its own challenges and advantages. So, when talking about sculptures, 3D scanning allows us to capture the texture, surface patterns, and their three-dimensional form. Sculptures may be vulnerable to wear over time, particularly those made of wood or other unconventional materials, so creating digital models helps preserve these features in their original state. 3D digitization can also be applied to flat artworks such as paintings. With advanced scanning technologies like structured light scanning, we can capture the texture of the paint, brush strokes, and any three-dimensional elements on the canvas. This type of digitization can provide valuable insight into the creation process, the artist's techniques, and the fine details that are often difficult to see with the naked eye. Plus, digital models of paintings allow for virtual restoration and accessibility in ways that traditional photographs cannot. Manuscripts and ancient texts are often extremely fragile and cannot be handled regularly, so digitizing them ensures that they can be preserved without the risk of physical damage. But beyond preservation, digitization also offers the option for interactive viewing of fine details. We can zoom in to see handwriting, ink marks, illustrations, and even the texture of the paper or parchment. An interesting example of this is the digitization of the Dead Sea Scrolls that include some of the oldest known biblical texts. The scrolls are so fragile and damaged that they will likely never be physically opened for inspection. Therefore, a 3D scan was created, enabling a virtual unwrapping and further research of the scrolls. Similarly, 3D models of pottery and ceramics can be used by researchers to study the origins, designs, and even the functional use of these objects, providing insights into ancient societies. They also enable researchers to digitally reconstruct objects that were broken or heavily damaged. In architecture, 3D digitization can be used to document fragments of historical buildings, reliefs, or monuments that may no longer be in their original location or have been damaged over time. These models can then be used for historical reconstructions or to better understand how architectural features fit into the larger context of a building or site. Digitizing archaeological artifacts allows researchers to study them remotely and without the risk of physical handling, which could lead to wear or damage. Furthermore, 3D models of these artifacts can be shared widely for educational purposes or virtual exhibitions. So there are several factors to consider when choosing an object for 3D digitization, and understanding these considerations will help ensure successful results. First of all, we need to mention size, shape, and material. Smaller objects, like jewelry, can require more precise measurement devices, while larger items, such as monuments or buildings, require specialized equipment like terrestrial laser scanners or drones for mapping and surveying. Objects with irregular shapes or intricate geometries, such as broken pottery or sculptures with raised details, can be challenging to scan accurately. The complexity of the shape may require more advanced scanning techniques or extra time to ensure that all details are captured. It's important to consider how the shape will affect the scanning process and determine which technology will be most effective for the specific form of the object. Material of the object can also play a critical role. Different materials, such as metal, wood, stone, ceramics, or textiles, require different scanning approaches. For example, objects with rough or textured surfaces are easier to scan. Also, priority should be given to objects made of materials which degrade faster, like wood or paper. Another important consideration is the condition and fragility of the object itself, as this may limit how it can be handled or scanned. Assessing the physical condition of the object is critical. Some items may be too fragile or deteriorated to handle for scanning. We also need to consider the potential risks of moving the object, adjusting the lighting, or using certain scanning technologies. For example, some objects may have delicate or worn surfaces that are vulnerable to accidental damage during scanning. Extra care is needed in these instances to avoid inadvertently compromising the artifact. To ensure the safety and integrity of the object, a museum professional should supervise each stage of the scanning process. Only trained professionals should handle the object, as they have the expertise to minimize risks and ensure proper handling during the scanning procedure. An important factor to consider is historical significance of the object. Some items may be of greater historical significance than others, with unique cultural, artistic, or scientific value. For example, certain objects may be one of a kind, or extremely rare, or even irreplaceable. These items may require heightened attention to ensure their preservation. Another consideration is the accessibility of the object. How easy is it to physically access the artifact? If it's in a remote location, in a private collection, or just difficult to handle due to size or fragility, digitization can provide an opportunity to bring it to a wider audience without needing to move the object or expose it to additional wear and tear. In some cases, the object may even be stored in a controlled environment that isn't easily accessible to researchers or the public. So digitizing it allows more people to interact with the object digitally. It's also important to consider how 3D digitization can support future research projects. For example, sorry, it can be particularly useful in delicate or remote archaeological sites where traditional handling may not be feasible or safe. So by creating 3D models, we can allow for more detailed, non-invasive studies. Another relevant aspect is the exhibition potential. If the object will be displayed in a museum or shared in virtual exhibitions, digitization can significantly enhance its visibility and public engagement. 3D models can be incorporated into online learning tools, virtual tours, or educational programs, making the object more accessible and allowing a wider audience to explore it in depth. This is particularly valuable for objects that are rarely seen in person or are housed in inaccessible locations. So, when deciding whether to handle 3D digitization in-house or outsource, sorry, it's important to first evaluate your team's existing skills, equipment, and resources. Consider whether your team has the necessary expertise and equipment to successfully complete the project, or if additional training or investment in new technology would be required for in-house digitization. Conduct a cost-benefit analysis to compare the costs of in-house digitization, such as equipment, training, and labor, versus outsourcing, which may offer efficiency and save time, especially for larger or more complex projects. If you choose to digitize in-house, assess how easily you can upgrade your existing setup and whether adequate support and learning resources are available. Regardless of the approach, ensure the team has a solid understanding understanding of the limitations of different 3D techniques to ensure accurate results. If outsourcing, it's essential to choose service providers with specific expertise in cultural heritage digitization to guarantee the project is handled with the necessary sensitivity, precision, and technical skill. This decision should be guided by an evaluation of your resources, project scale, and the best value for the preservation of the cultural heritage at hand. Okay, so as we explore 3D digitization of cultural heritage, it's extremely important to consider the ethical aspects of the process. There are several key factors to keep in mind to ensure the digitization process respects the cultural and legal rights of communities and individuals. When digitizing objects from private collections or indigenous groups, securing permissions is essential. This helps avoid legal or cultural disputes down the line. Always obtain the necessary consent from the relevant parties and adhere to ethical guidelines to ensure that the digitization process aligns with the community's interests and values. This is particularly crucial when dealing with sensitive or restricted collections. Some objects may hold deep cultural significance, and digitizing them can raise ethical concerns. For, for example, sacred objects or items tied to spiritual practices may need special consideration. In some cultures, reproducing such items digitally may be seen as disrespectful, and in these cases, it may be necessary to exclude them from digitization efforts altogether. A notable example is Chinese paper gods, which are designed to be burned in rituals to honor ancestors and deities. Digitizing these objects can be problematic as it may detach them from their sacred context, or commercialize or misrepresent their spiritual significance, therefore violating cultural protocols about how these items should be treated or viewed. It's important to always engage with the community or custodians of these objects to understand their cultural context and ensure that digitization does not violate their beliefs or values. Compliance with cultural heritage laws is another critical consideration. Different countries have specific regulations that protect cultural heritage, and international agreements like UNESCO conventions provide frameworks for safeguarding cultural assets. It's essential to familiarize yourself with both local and international heritage protection laws to ensure that your digitization efforts are legally sound and do not inadvertently violate these protections. By taking all these factors into account, we can ensure that digitization serves the best interest of both the objects and the communities they represent. So before we can begin the actual scanning process, careful preparation is key. The goal is twofold. First, we want to ensure that the objects are handled in a way that can protect their physical integrity, preventing any damage during scanning. And second, we aim to capture the most accurate and high-quality data possible to create precise digital models. This preparation phase involves assessing the condition of the object and preparing both the object and the environment to ensure optimal results. So, as we all know, many cultural heritage items, especially those of historical significance, are made from fragile materials which are often sensitive to physical stress, environmental changes, and handling. So, when preparing an item for scanning, it's crucial to document its condition first. This allows us to note any pre-existing damage, ensuring that any new wear or issues can be clearly identified and prevented during the scanning process. To ensure the safety of fragile objects during scanning, specialized equipment is sometimes necessary. First, handlers should always wear clean, lint-free gloves. Artifacts should also be supported properly to avoid any deformation or damage during scanning. This can include using padded stands or custom-fit supports that keep the object stable without risking strain or shifting. In some cases, temporary support structures or harnesses may be required to maintain the integrity of fragile items. Before scanning, artifacts should be cleaned to remove dust and debris that could interfere with accurate scanning. Some artifacts may have highly reflective or uneven surfaces that make scanning difficult. For example, polished or glossy items might not capture surface details accurately. In these cases, applying a temporary non-invasive coating can help create a matte surface, improving scan quality. It's very important, though, that these coatings are non-permanent and easy to remove after scanning, ensuring the artifact's original condition is preserved. It's also important to secure the scanning platform as to minimize the risk of the object toppling or breaking due to instability. If possible, there should be free space surrounding the scanning platform to minimize operator error, such as tripping or bumping into other objects while scanning. Environmental conditions like temperature and humidity are also crucial. For materials like wood, paper, or leather, extreme temperature or humidity changes can lead to expansion, contraction, or warping, accelerating degradation, which can affect the scanning process as well as the object itself. Keeping the scanning environment within a controlled range is essential to minimize these risks. Lastly, light sensitivity is another concern. Some artifacts, such as textiles or objects with certain paints, can be sensitive to light exposure. It's important to use indirect lighting or scan in low light conditions, if the scanning technology allows for it, to reduce the risk of fading or deterioration over time. Continuous LED lights with a light diffuser are ideal as they give off less heat compared to conventional lighting techniques. And by following all these practices, we can ensure that the scanning process captures high-quality data while safeguarding the physical integrity of the artifacts themselves. So that's it for me. Thank you for listening. I will let my colleague Matea take you through the next part of the process.
Thank you, Ivan. Today, we will present a basic process of 3D digitization requiring no professional equipment and knowledge. For this demonstration, we've chosen a small statue which features a lot of intricate details, making it a great subject for the process. Despite the complexity of the object, we'll show you how to capture it in 3D with just two essential pieces of equipment: a mobile phone and a computer. There are several ways to create a 3D model, but photogrammetry is one of the most widely used methods. This process involves taking multiple photographs from various angles and then using software to reconstruct the 3D model based on these images. The more images you take, and the better the accuracy and details are, the better the result will be in the 3D reconstruction. When creating a 3D model, the first and most important step is data capture. The quality of the 3D model depends on the precision of the images you take. This means that every image should capture the fine details and complex geometries of the object you are digitizing. If the images aren't sharp or if key areas are missed, your final model won't accurately represent the object. Before you begin shooting, you need to set up both your device and the environment for optimal results. For high-quality images, it's advisable to control your camera settings manually. However, this is not essential. So now let's go over the settings. The first one we'll discuss is shutter speed. This determines how long the camera shutter remains open. For example, for clear, well-lit images, it's advisable to use a shutter speed of 1/125. In lower light conditions, we may need to decrease the speed slightly to allow more light into the sensor. But be careful, because using too slow of a shutter speed without a tripod can result in blurry photos. Next, we have ISO sensitivity. ISO controls how sensitive the camera's sensor is to light. Setting the ISO to 200 offers a balance of good image quality and minimal noise. Higher ISO settings can introduce digital grain or noise to the image, reducing its quality. Higher quality cameras have a higher natural ISO sensitivity and thus can capture better images in low light conditions. Another important setting is white balance. This setting adjusts the color temperature of the light in your photos. For objects under warm lighting, like the typical indoor lamps, you might set the white balance to 2700 Kelvin. Under fluorescent lights, the white balance might be closer to 5000 Kelvin. But the best method is to take a picture of an empty white paper. If it looks white on the photo, the white balance is correct. And this helps to ensure that colors look natural and that the details are accurately captured. Okay, moving on to focus. You want to ensure that your focus is sharp. By selecting a manual focus and setting it to the desired value, you can ensure that every part of the object, no matter how detailed, remains clear. Always use manual focus to avoid automatic adjustments that might blur important details. And some devices have a helpful indicator that marks the parts of the image in focus. Make sure to carefully focus on key areas, especially intricate parts of the object. And lastly, we come to resolution. The higher the resolution, the more detail you can capture. Use the maximum resolution available to ensure that you have as much detail as possible to reconstruct an accurate 3D model. And keep in mind that these are just suggestions. The settings ultimately depend on the room and lighting conditions. Trust your judgment and feel free to adjust them accordingly. It's always a good idea to take a few test photos and inspect them on a large screen to better assess the validity of the settings you used. Okay, now that everything is set, it's time to actually take the photos. And there are a few important things to keep in mind. First, consistency in distance and focus. As you move around the object, it's crucial to maintain a consistent distance from the object. This is particularly important if you are using manual focus settings, as any change in distance or angle could affect the sharpness of the image. A consistent focus ensures that every part of the object remains equally sharp in all photos. If you need to move in closer to better capture detail, adjust the focus accordingly, but do so sparingly. Now let's talk about proper lighting and angle considerations. Good lighting is key to capturing the finest details. So always make sure that the light source is well positioned. Avoid blocking the light with your camera or your own shadow. Properly illuminated objects will have more contrast and depth, making them easier to reconstruct in 3D later. Large diffuse light sources are ideal, but any light is better than nothing. Try to avoid small intense light sources as they will result in sharp reflections on the object. Another important thing to keep in mind is photographing for multiple angles. A 3D model requires images from different viewpoints to ensure that the software can capture all the details of the object. So take photos from various angles, ensuring you cover the entire surface. Each image you take should have at least 70% overlap with the last image you took, as you can see in the example on the slide. This enables the reconstruction software to match up the photos later in the process. And one of the ways to do this on most objects is to divide up the photography process into 4 stages. So first, taking photos from below the object. Then, taking photos from the height of the object. Then, taking photos from above the object. And finally, taking photos of the details. Ideally, this will split up the process into 3 orbits around the object, each capturing different viewpoints on the object and filling in all the spots that were missed with detailed photos. In this example, we took around 120 photos. And lastly, try to make the object as big as you can on your photos. It's important that most of the space on the photograph is taken up by the object. This will reduce time wasted reconstructing parts of the environment in the later steps of the process and will also give you the most amount of data about the object. If possible, crop out or block out the background with physical barriers or in a photo editing software. And what are the key challenges in capturing complex geometries accurately? Well, one of the main issues is lighting. Intricate objects often have varying surfaces that reflect light differently. So you should ensure you have diffused light to minimize shadows and highlight variations that could distort the model. Pay close attention to shadows and highlights, especially when capturing intricate features. And another challenge involves variations in angles. Some objects, especially detailed sculptures or architectural features, require capturing from numerous angles. You may need to photograph complex shapes from hard-to-reach positions to ensure full coverage. Okay, before diving into the processing steps, let's talk about managing and storing your data properly. So firstly, it's important to keep your images well organized from the start. You should save your photos in a structured format so that you can easily access them throughout the project. We recommend using both JPEG or PNG and RAW formats for storing your images. Raw materials contain extra metadata that can help fine-tune your JPEG files if needed. Moving on to file organization. A good practice is to keep your files organized in a dedicated working folder. By placing all your images in one easy-to-access location, you'll save time during processing and avoid the risk of losing or misplacing your files. And finally, backup your data. So always backup your files, especially your raw image data and final models. Losing this data can set back your project significantly. After capturing the images, the next step is creating a precise 3D model. To convert those 2D images into a 3D representation of the object, a software is used. One of the most widely used tools for this is Agisoft Metashape, a powerful photogrammetry software that helps convert your photos into 3D models. It's an industry standard tool for creating 3D models from photographs. However, you can also use an open source software such as Mushroom. Mushroom is a powerful and free photogrammetry tool that uses your images to build accurate 3D models. One of the key advantages of Mushroom is its ease of use. It's designed to be accessible even for those new to photogrammetry while still being flexible enough for advanced users. Okay, now let's dive into a step-by-step breakdown of data processing. So once your data set is ready, the next step is importing the images into Mushroom. And here's how you do it. First, of course, you open Mushroom software on your computer. The next step is to drag and drop your images into the Images section in the leftmost part of the viewport. In our case, we imported around 114 photos from the around 120 that we took. We discarded some of the photos because of their low quality. Then you wait until the photos are uploaded. Mushroom automatically reads the metadata from your images, such as camera settings and lens type, if available, which helps in the reconstruction process. If your images don't have metadata, you may need to manually adjust camera parameters later or take some time in the beginning of the process to automatically reconstruct the parameters. Okay, as you can see, the photos are now uploaded. You can see them in the images section. The next important step you should take is to save the project on a secure location on your computer. You can leave the settings in default mode, then click Start to begin the process. The duration of the process will depend on the processing capabilities of your computer. The software will go through several stages during the process, and you can see the stages in the lower part of the screen, but it's quite automated, with Mushroom handling most of the heavy lifting. However, it offers flexibility and customization for those who prefer a more tailored approach. If you notice any problems, such as gaps in the model, you can always take more photos of the problematic area, add them to Mushroom, and repeat the process. Also on the right side, you can view the process of photogrammetry in the 3D viewport, where you can see the result of each step. Okay, and the final step is refining the model, which can be done using several software. We are using Blender due to its open source nature and a wide array of tools available. But any mesh editing software may be used, such as 3D Studio Max, Maya, Mesh Mixer, and many others. Refining the model might include things like filling holes, smoothing surfaces, etc. However, this part of the process requires some experience in working with the software. If you've never used a mesh editing software or you are new to it, you can, as we already mentioned, try taking more photos of the problematic area to ensure getting the best results. So the files you wish to import to Blender will be located in the Mushroom folder you use to save the project in the subfolder texturing. And the file you wish to import will be the one with the OBJ or FBX extension. The next step is the rough cleanup. So the first thing to do after importing the file is to position it at the origin of the coordinate system and orient it to make it easier to navigate. After that step, we start with removing unwanted geometry. In our case, we deleted the surface below the object and few specks that were floating around the object. Depending on how well you took the photographs, you may have a lot more or less geometry to clean up. Keeping the rest of the photography out of focus helps with keeping the reconstructed geometry clean. Also, we used a smoothing modifier to reduce the noise, but we did it sparingly. When using a smoothing modifier, it's recommended to use a low factor, such as 0.15, with a high number of iterations, such as 50 to 150, to keep the main parts of the geometry intact and just smoothing out the noise. Now let's move on to the next step, the fine manual cleanup. In this part of the process, we use the Blender Sculpt mode to refine the shape manually. This is something we did sparingly, but it's sometimes necessary to fix mistakes that might have occurred during the scanning process. We primarily use the Smooth and Sculpt tools to further reduce noise and fill in any gaps in our model. It's best to do this while closely observing the object, as it helps avoid introducing manual mistakes while refining the shape. Also, we toggle the texture preview on to examine the image projected onto the 3D model. So to put it simply, this adds color and texture to the 3D model. And as you can see, colors will make imperfections less obvious. Or in other words, they help hide any imperfections that might still be present. And you can also see that a gap remained in the base section of the model due to reflection. This could have been avoided maybe by using software lighting or using a polarized filter. However, as demonstrated in the video, it can be corrected in Blender using the Sculpt and Smooth tools. Okay, and the final result is here. After the rough and fine cleanup, you have a 3D model that's ready to be used, whether in VR or XR, or simply for rendering a video. All that is left to do is to export it. And it's recommended, again, to use the OBJ or FBX formats. So now that we completed the data processing stage and exported the model, the next step is determining how to present it. Your presentation approach will vary based on your objectives and audience. So let's go over some of the most effective options. You can share your 3D model online through interactive viewing platforms. This allows others to view and explore the model, zooming in on details, rotating the object, and interacting with the model as needed. Popular tools for this include platforms like Sketchfab or Model Viewer, which allow you to embed models into websites for easy access and interaction. Another method of presentation is through 3D printing. With the 3D mesh, you can create a physical replica of the object, and this is especially useful for preserving cultural artifacts or creating prototypes. 3D printing brings the virtual model into the physical world, making it tangible for presentations or exhibitions. A more innovative way to present your 3D model is through augmented reality. This allows your audience to view the model in a real-world environment using AR apps or devices. With AR, you can bring the 3D object into any space and interact with it in ways that traditional 2D images or videos cannot offer. Tools like Unity can be used to create AR experiences for your model. And finally, you can create a video render of your 3D model. This method allows you to showcase the model from various angles, zoom in on specific details, and even animate the object to highlight its features. Video rendering is a powerful way to present your model in a polished and dynamic format, perfect for promotional materials, tutorials, or online presentations. So these presentation methods provide flexibility and enable you to showcase your 3D models in ways that best fit your needs and capabilities, whether for digital viewing, physical replicas, or immersive experiences. Okay. Finally, let's take a look at the final result, a video render of the small statue. So this was created using basic equipment, just a mobile phone and a computer, while following the simple steps we've outlined in the webinar. As you can see, despite the simplicity of the tools, the result is a detailed and dynamic 3D representation of the statue, demonstrating the power of this accessible process. As we wrap up today's webinar, let's quickly recap the key points we've covered. So first, we talked about choosing an object, where we emphasized the importance of selecting a subject that's suitable for 3D scanning, taking into account factors like size, complexity, condition, and texture. Next, we moved on to preparing the object. This step is all about making sure the object is clean, stable, and placed in a well-lit environment to ensure the best scan quality. Then we got into recording. This involves capturing high-quality images where we focused on key camera settings and techniques that help capture fine details and geometries for an accurate scan. After that, we touched on data management. We discussed the importance of organizing your images and storing them in structured formats for smooth processing later on. Following that, we covered data processing, which includes the essential steps of importing and processing the images to turn them into a 3D mesh. And finally, we explored presentation. We highlighted the different ways you can present your finished 3D model, from interactive viewing to 3D printing and augmented reality. And that's it. Thank you all for joining today's session. We hope you found it informative. Before we wrap up, we have some exciting news to share. We've been working closely with Europeana to develop a new course for the Europeana Academy based on our first RCtoDC webinar that was focused on the implementation of standards in management of cultural heritage. We are very excited to share this learning experience with you all very soon, so please stay tuned for more details. And finally, we would also like to invite you all to follow us on our website and social media accounts for more information about the project, and also stay tuned to hear about our future webinars. And before I let you go, we'd love to hear your thoughts. So if you could please take a minute to fill out our feedback form. Your input helps us make future sessions even better. And we also encourage you to try creating your own 3D models and send us your results. We'd love to share them on our social media. If you run into any issues along the way, don't hesitate to reach out for help. I believe our email address is on the screen. And remember, don't be discouraged by any challenges you encounter. If you don't succeed the first time, keep trying, because as we all know, practice makes perfect. And we look forward to seeing your creations, and we also look forward to seeing you on our future webinars. Thank you very much, and have a nice day.